All right, guys, we are going to do a little reminder today. This is something that you should have learned in Algebra 1. And I feel like most of us know these things, but it'll be a good reminder, and we can practice with some slightly harder numbers. So we're going to do a little exponent reminder today. We're going to do that on page 74. Yeah. All right. So we turn to 74 here. Oh my goodness, my desk is a mess. We should have this little one that we're gonna put on there. Actually, I wanted to cut out all these little individual doors. Maybe I'm gonna do that real quick. If you want to skip ahead while I'm doing that, that is completely understandable. And we also have a magical book that I'm going to kind of put towards the bottom of the page here, just so we can maybe have some space to write some stuff at the top. Okay, so real quick, I'm going to cut each of these individually here, just to be able to talk about them a little better. Okay, alrighty. So here's our little exponent reminder. Again, these are things that hopefully we know. Like if I'm multiplying two letters that are the same or two numbers that are the same and they have exponents, then we should add those exponents. So as a cute little example, I could do something like 5 to the half power times 5 to the 1/5 power. And so since my big numbers, my base numbers are the same, it's going to be 5 to some power where I have to add 1/2 and 1/5. And here's where we can get a little interesting because you thought I was going to make it easy and just give you numbers. Nope, we're doing fractions. So if I want to add these fractions, I have to have a common denominator. And so my common denominator here would be 10. And so I'm multiplying this one by 5 and this one by 2. And then I can add, because they have the same denominator, so we'd be looking at 7/10 as my final answer there. Now, if I have a number with an exponent and then it's raised to another exponent, here we multiply. So like a power to a power is multiplication. When we are multiplying powers, we add. So cute little example of this is if I had 7 to the 1/4 power to the 1/3 power. So we have a number to a power, We're going to multiply. So your 7 stays the same, but we're multiplying these exponents here. And actually, multiplying exponents is not so bad because we don't have to have a common denominator. We just multiply straight. So 1/12 would be my final answer there. Okay. If I have parentheses like this, that does imply multiplication, but if I had more than one number in there, so like I have a number A and a number B in there, then this M gets distributed by multiplying to each exponent. And every number or every letter has its own exponent. Even if you don't see it, it's always a hidden one. Okay, so we need to be careful. So a quick little example of this could be if I had 4 times 5 to the 3/4 power to the 3rd power. Okay, so every number, every letter has a power. So this 3 needs to be distributed to 4th power, which is just 1, and then to the 3/4 power. And again, we're just multiplying. So 1 times 3 is 3, so like 4 to the 3rd. And then here, if I do 3/4 times 3 over 1, we're going to have 5 to the 9/4. Yuck. And I guess we could kind of do 4 to the 3rd because like that's actually easy. That's 64. So this is just 64 times 5 to the 9/4, whatever the heck that means. We will soon find out. Okay, negative exponents are kind of weird. You're not really allowed to have them. So if I have a negative exponent, the thing I like to think about is we're going to move the number and exponent to become positive. So here it was like in the numerator. I need to move it to the denominator for it to become positive. So move your number and your exponent from like wherever it is so that it can become positive. As long as you move it, it's positive. Okay, so an example of that could be if I had 3 over x to the negative 7th. The 3 has its own power and it is 1. So it's going to stay in the numerator. However, the x has a negative exponent of 7, so it needs to move to the numerator with the 3 so that it can become positive. So you're not moving all the numbers, you're just moving the one that has a negative exponent. Okay. A couple more here, and then we're going to try some more examples. If I am dividing, then we subtract. And I kind of like that. I kind of hate it. I always actually subtract with an absolute value and then keep the number wherever the exponent was larger. So keep number where exponent is larger. And the reason I do it that way is so then I don't also have to think about moving a negative. Because sometimes when we subtract, we get negative numbers. But if I subtract with an absolute value, then I'm always positive. And then I just put the number wherever the larger exponent was. So again, I think this will be a little easier when we see an example. So I'm going to kind of try 2 of these. So for example, if I had 7 to the 3/7 over 7 to the 5/7. This is actually not so bad for me to subtract in my head because they do have a common denominator. So I can do 3 minus 5. Now if I do 3 minus 5, that's really -2, and then I have to worry about a negative exponent. So instead of all that, I just subtract with an absolute value. And so really we're 2/7. And I'm going to put that wherever the larger exponent was. So 5/7 is larger than 3/7. So your 2/7 is going to stay at the bottom, which means you just have to have a 1 placeholder at the top. So that's what I mean by subtracting with an absolute value and then keeping your number where the larger exponent is. So another example could be 4 to the 2/3 over 4 to the 1/3. And again, that's pretty easy to subtract these because they have a common denominator. So 2/3 minus 1/3 is 1/3. And the larger exponent is on top. And so we're going to have 4 to the 1/3 on top. No need for a 1 on the bottom. We don't need a bottom number. Okay. Last but not least, I can also distribute an exponent on the outside of parentheses to fractions, and you should. So when we're distributing, we're multiplying. Okay, so a quick little example of this. If I had something like 4m to the 6th over n to the 3rd to the half, inside my parentheses, I have 3 individual number letters. 1, 2, 3. All of them need to get the half. So the half is going here, the half is going here, and the half is going here. So we're multiplying half by all of them. So we're going to have 4 to the 1/2 power, because currently 4's power is 1, and 1 times half is half. We're going to have m to the 3rd power, because half of 6 is 3. And then n is in the denominator, and 3 times half is just going to be 3 halves, so 3 over 2. It can get real messy and real tricky when you have to do multiple rules at the same time. And then we just have to be real careful. Like I might have to distribute and divide later. Like if these variables were the same, I could subtract the 3 and the 3 over 2. So just be careful of that. Which hopefully we'll see some of those examples in here. Maybe I didn't need to leave that space there. This is just more, let's skip this. Let's go here. Let's try some of these examples. Okay. Oh, well, I can't do anything on that one because your big numbers have to be the same. Maybe that's what I can put here. So when I have something like 5 to the 1/4 power, this 5 number, your big number, is called the base. We need the base to be the same, and it stays the same. Like you don't multiply them or do anything with them. They always just remain the same. If they're not the same, then you kind of can't do stuff. This right here is your exponent. That's what you're doing stuff with. You're going to maybe add it or subtract it or multiply it or whatever. Okay, so because my base numbers are not the same, I can't really do anything. So already simplified. But here I can do something. So let's try that. Like, oh, I kind of went in the wrong order. Let's go down here. Sorry. Here I can do something. I can't like multiply these because they're not the same, but I can distribute because there's a 3 on the outside of the parentheses. So when we distribute, we multiply, and 3 times 2/3 is going to be 4 to the 2nd because the 3 sort of just divide out, times 5 to the 9/4. And then I could probably do the 4 squared. That's 16 times 5 to the 9/4. That's kind of all I can do. Here I can subtract. I think maybe I did this one already, but that's okay. Because the base numbers are the same, so we keep it the same. And we subtract. It will be in the numerator. Sorry, I went a little fast there because I noticed my numerator exponent was larger. And so when we subtract, that's not so bad. It's 1/3. Here I can distribute because we have parentheses. And so we'll have 3 to the 3rd power because the 2's will just divide out, which I can do that. That's 27. Cute. Here I can distribute. So we'll have 54 to the 1/3 over 64 to the 1/3. That's kind of it for now because those numbers are not the same, so I can't subtract. And then lastly, we can distribute. So we'll have 6. I got to line these up. I hate when my fractions are sideways like that. So we have 2 over 3 times 3 over 4. The 3's divide out, the 2's reduce, so 6 to the 1/2 power. Cute. Okay, let's try some more. Here, we do have the same base, and when we're multiplying, we can add. And luckily, these fractions have the same denominator, so we can just keep the denominator 3, and we'll have 5/3. Love that for us. Working our way down, here we're going to subtract because we're dividing. My goodness. And right off the bat, I noticed that the denominator is larger. So my x is going to stay down there, which means we need a placeholder up here. When I subtract, that's not so bad because my denominators are the same. And we're going to have 3. Oh, so it's going to be 3 over 3, which is really just 1. Which I kind of don't need, so just 1 over x. Next one here. Sorry, I got distracted by an email. We have parentheses, so we're going to distribute, which means we're going to multiply. And again, freaking, I hate when my fractions are sideways like that. 3 over 2 times 1 over 2. Okay, so we can't cross cancel here. We're going to be 3 over 4. Bummer. Here we can distribute, we can multiply, so 5 over 6 times negative 3 over 1. So I can cross multiply a little bit on that one. So x to the negative, 5 over 2. Can't have a negative exponent, so currently this guy is in the numerator. We're going to move it to the denominator so that it can be positive. Here I have parentheses, so I'm going to distribute to all my exponents. So 64 to the 2/3 over x to the 2/3. These are not the same, so I can't subtract. And here we're going to distribute. So 8 to the 1/3, x to the 1/3. They're not the same, so I can't add. And there you go. Little exponent reminder for you. I'll see you on the next one.